for innovators and startups based in India, but with markets anywhere in the world. So, as you all know, we're coming out of the lockdown phase of coronavirus. And while the big focus in the last 2.5 months was on lives and safety, now going ahead, the focus is on livelihood, innovation, and so on. And again, as you all know, a big acceleration was given to digital transformation. So, thanks to work from home, everyone's been using digital tools and so on. There were also some very interesting stories in the news about robots being used in the healthcare sector. For example, robots in Kerala apparently greeting passengers at airports and so on, or in hospitals, telling people what the procedure is. There are other scenarios people are talking about of robotics in the healthcare industry for testing to minimize physical human to human contacts and so on. A lot of interesting scenarios going on. So today we have three people from very interesting sectors. The first speaker is Raghav Gupta, co-founder and CEO of Nimble Robotics, which looks at robotics assistance for the kitchen. So all those of you who are sick of cooking from home, hopefully we'll get some tips from Raghav. No, just joking. Then we also have Gokul NA, who is the founder and CTO at Sinler, which stands for Cybernetics Laboratory. It's a specialist in visual object intelligence for industrial automation. So sort of connecting the software, the hardware worlds in that sense. And joining us also, we have Pratyusha Chilagani, who's formerly at Intel, but director currently of a company called Footloose Labs, which is autonomous robots for the pharmaceutical sector. So three very interesting speakers. Let me jump into brief introductions for the bios. You will find these online afterwards. Raghav Gupta has founded a company called Nimble, which helps consumers put home cooking on autopilot, and they build domestic cooking robots. He is an electrical engineer by training, shuttles between Bangalore and San Francisco. His hobbies include playing video games, reading, and trying out new productivity tools. So I guess this has been a very good time for him to check out new tools. Joining us also is Gokul NA, who specializes in visual intelligence for object manipulation. He's been doing this for over 11 years. He grew up on a farm and he attempted to do robots which could climb trees and do harvesting. Then he moved on to a company called National Instruments, where he met his co-founder, Nikhil. After working on over 40 projects on machine intelligence and visual recognition, they decided to strike out on their own in March 2015, 5 years ago. So they got funding also from venture capital investors in 2019. And now they're looking at how to help robots handle objects for industrial scenarios. And third, we have Pratyusha Chilagani, who has worked in physical failure analysis at Intel in Arizona before she returned from the US, spending 3.5 years in the US. Now she's moved to a completely different field, robotics, and is director of a company called Footloose. Her general challenges she faces and she tackles for these companies are in robotics and AI. Some fun facts about Pratyusha. She also likes Western classical music and loves podcasts on AI, physics, cosmos, etc. These are very good times, I guess, for you. Thanks to all this Elon Musk and Tesla SpaceX going to space and so on and so forth. So this is going to be a very nice and lively discussion. I'm going to start off with a few questions. I welcome all the attendees. Once again, thanks to all the attendees for joining. You can type in your questions in the chat window and we take them at the end. I've got a few questions to run through and then we'll come to the questions at the end. Thanks again to Cloud Product for hosting this. Thanks especially to our three speakers who will now share with us some of their insights on robotics. So to set the stage, my first question for all the panelists one by one is, we've heard about robotics and robots for 30, 40, maybe even 50 years, perhaps longer. There are a lot of stories about them, expectations about them. They've been in science fiction movies, utopian, dystopian scenarios, etc. But recently things seem to have changed a lot. So something has changed either in the technology, trends, use cases, and so on. So my question to the panelists is, what has changed recently to make robotics so popular all over again? Let's start with you, Raghav.
Okay. Thanks so much, Madan, for the very lovely introduction and for throwing the first question right at me. But so the way I look at it is, robots have been around for 50 years, and the biggest factor that the biggest advantage that it claims to bring to society has been cost saving. It has been that robots would help save us time and money. Time leads to cost again, and I would like to answer that question from a cost perspective. What has happened, if you look at why would humans use robots? They would use robots because it increases, because cost saving increase. Cost savings are essentially the delta between the money they have to spend on operating and building a robot, as well as the difference between that and doing something without a robot. Now, what has happened is two things have happened. A, the cost of doing something without a robot has increased exponentially, because earlier, doing something without a robot included just labor wages, or the salary cost that one had to give out to get some task done. Now the costs are not just wages, but it is also health costs associated with the life of the worker who's doing the job, as well as the life or the health of the person who will at the end get impacted. There is obviously no value to human life, and hence the costs are now exponential. Consequently, the price of operating a robot has come down significantly. Not just operating, but also building a robot. Electronics are much more cheaper than they were maybe 5 years back or even 2 years back. B, the very talented engineering community has literally open sourced everything that is out there. You have open source computer vision algorithms, you have the open AI initiative, you have a bunch of other things. There are open source tools, there's TensorFlow, there is a ROS, there's a bunch of stuff that is out there, which in the heyday, and in the heyday, the companies had to build all of these tools, all of these algorithms, all of this in-house, because the community has basically made it available. The cost of manufacturing a robot is much more cheaper now. What that results in is bigger cost savings, not just monetarily, but also in terms of health. And I think that is primarily the only thing that has changed, if I look at it from a cost angle. But what do you think, Gokul?
Gokul, yeah, great. That's a good segue to you. Anything you want to add to that?
So some factors are very clearly aptly put by Raghav. So if you see this attention that robotics is catching now is not the first time it's actually happening, like you mentioned. There have been some cycles before, right? It comes up, it again falls down, it again comes up, and again falls down. 1961 was the first commercial robot that came out, in fact, and again it died within 10 years. And again in 1981, when ABB brought out the first robot again into it, and Kukas, and these guys commercialized robots were coming into the industry, there was again one more revival that happened. The assumption that has always been there with it every time when they attempted is an attention lapse towards the problem, the assumption that used to happen around the problem. And every time they realized that, oh, it's not commercially viable anymore, it's not matching what are the costs that we actually matched at that point. And then again, it died out, and again, it came up. But this time, it's a lot more promising. And every time when it actually fell down, there was one hype. It didn't settle back to where it was. It settled back to somewhere, to a better stage in automation than what it was before. Like this time, there has to be a little more of huge jump because of the advent of what has happened with AI, the abstraction of AI, but mostly prominently in ML and second, it has also caught the popular imagination of what robots can do, because we are showing a lot more things with ML in a lot of other fields. So then it comes again, why not, right? It's alignment of it. It's rather alignment of multitude of different factors. Every time then when market interests actually have to align, the tech challenges, I have solved these many things, so what's more is challenging. That's what the enterprising tech disruptors and thinkers actually want to explore with. So they go around one phase of problems, let's say entire from 2000 to 2010, it was all internet-based things. And then again, if you think about 90s, it's all about the communication and, communication compressions and things that happen. So that's a cycle that actually happens. So that's one factor. On the other hand, again, market and where the funding and where the trend of talks actually happens. So all this has blended, but industries have been adopting robots, but this, when it comes to a common imagination, it also catches a lot more drift and wind. And that, I think, has a large play to do with how we are approaching towards. And added to it, there is supporting, tech is also aligning along with this interest. Now, the tech growth and tech, discoveries that you have made, inventions that you have made, it's also aligning. So that might be even before this COVID-19 happened, there has been a very huge, like past 1 year almost, there was a lot of investments angle changing, because we exhausted a little bit of consumer market also. And there's a revival towards, okay, what's left more for us to go. So it's like a helical process. Society always grows that way.
Yeah, it's like a spiral, not a
wave. Spiral,
so we'll come back to that COVID question that you mentioned a while ago. But let's turn to you, Pratyusha now. Pratyusha, you got a very interesting background. You are both an insider and an outsider in the field of robotics, so you can see it from a very different vantage point. So what do you see as the reason why suddenly there's a big buzz around robots all over again?
I personally think, a lot of the, if you take production, or, logistics, warehouse, it's all process driven. In many of the, industries are heavily process driven. And, there is tech advancement along the side. So the automation seems to be the, number one priority, to have these processes streamlined, to have these processes optimized and sped up to increase their production and reduce the time cost, etc. Previously, that wasn't the case because there wasn't that much data available, and the tech advancement is not as was not as exponential as it is now. So I think the tech advancement, I attribute a lot of the hype and very reasonably so, to really the tech advancement for robotics to surface at this scale right now. Hello.
As some of you mentioned earlier, some of the early implementations of robotics were more in the B2B kind of space, industry, factory floors, and so on. And much later, it came into the consumer space. In Japan, we hear about robots for elder people and automated home cleaning robots, and so on and so forth. So let's begin with you, Gokul, this time. What do you see as differences between the B2B and the B2C scenario for robots? So what are some differences? What are some challenges? Where are the market opportunities for people who want to look at robots in the lives of consumers versus lives in factories and manufacturing plants, pharmacies, and so on? So you want to start with that, Gokul?
Yeah, sure. So if I think about it, one thing is how much have I actually thought about from the B2C perspective? That I would say is a little limited on my end, and because prominently my attention had been towards B2B and practice towards it. One thing is very clear is that the ecosystem is a lot more ripe for B2B because it's built to accommodate even a very nascent stage of a robot, right? It's harder, it's a much more heavier challenge to do for B2C, and it's complicated, it's much more sophisticated and challenging on a good way. In fact, that you need to be aware of cognizant of a lot of different changes that the system has to handle. Whereas in factories always aim to minimize that changes. They try to strategize things in such a way that anything that is only unavoidable to change are the only things on which you have to put a lot more intelligence and then operate on it. Otherwise, you try to mechanize and then streamline everything. So that way, B2B is kind of easier, had been easier for the robots to penetrate. Also the reason why robots penetrated into the B2B. People, in fact, if you see the 1961 video of how that robot was, it was about serving in the kitchen and then picking it and then washing it and trying to do all those activities. But it found its place eventually in B2B simply because, especially in factories, even in B2B, especially in manufacturing lines, because whatever Ford did in investment in making things more streamlined and bringing that idea to the world, and GE adopting it and GM adopting it, and everybody across the globe standardized discrete manufacturing in a particular fashion and made sure that everybody is more productive. One person doesn't do more than one particular action. Became much more easier for even non-sophisticated machines, not robots, to easily adapt to automation. That even increased the adoption rate for robots. So that's the only key reason why penetration has been much more higher. And since they were acting with machines more, people had been also a little more aware of robots in B2B and its limitations, or where the machines come from, where do they go into. So that's the advantage that I see with the B2B, where it's rightly placed to absorb robots in whatever the tech nascency stage where it is today, at least in the industrial robot side and the segment. So I don't know about B2C. B2C is, as I practically see it, this ecosystem is kind of lapsed, and the robot has to be much more sophisticated to be able to scale up beyond this to handle all those problems that are there. So yeah.
How about you, Raghav? Where do you sit on this position?
I would go back on the very fundamental thing that I was talking about, that it boils down to labor plus hygiene. In the heyday, where robots will be used was dependent on where it is saving the most amount of cost in terms of labor. Today, it will be in terms of how much cost it is saving in terms of labor and lives or hygiene. In the B2C space, areas which permeate both labor, which is human effort, plus hygiene, would be things like sports and exercise, because you still have to mingle with people and you have to exert effort. Food, because again, hygiene, and then someone has to cook your food or someone has to deliver your food, which is again both obviously telemedicine, like there's no doubt about it. Then there is home entertainment, because there was the effort of, say, going out with friends and playing paintball, which was something that required human dexterity or effort, and close proximity of people with each other. Um, so in home areas or B2C areas, almost all areas where any element of hygiene is involved, um, robots would get permeated. Um, I do not think for things like consumer toys, it will make much of a difference, because hygiene factor is not really involved. For B2B, I would be on the same lines. I would say the same thing for B2B, which Gokul said for B2C, which is, I'm really an outsider and there's not much I can say. But one thing I can say is I agree with Gokul on the fact that it is much easier to permeate B2B. You have a closed environment, which means that motion planning, trajectory planning is simplified for you. Your robot knows the kind of environment they're dealing with. But as self-driving and other innovations in the consumer spaces have shown, now robots are much more intelligent and adept to deal with environments which are not really closed, which are which cannot be predicted. And people who can solve problems in the B2C spaces, although harder, are targeting much bigger opportunities. I think self-driving is the case in point.
Got it. Pratisha, what about you? How are you looking at the B2B and B2C spaces in terms of differences, trends, opportunities?
Yeah, B2B, I think I agree with Raghav and Gokul. Um, with B2B, the problems are very predefined. The problem statement is predefined. The variables are predefined. So
Sorry,
with
Pratisha, can you
engineering,
just speak up a little bit? Your voice is a bit
can
soft.
you
Yeah,
can
yeah,
is
that's
it
better.
better now?
Yeah, yeah, yeah,
Better? Yeah.
yeah.
So what I was saying was in B2B, the problems are pretty predefined. You have a target problem to solve, and the variables are pretty fixed. So the most important thing is, while engineering, that you are accommodating for all the variables, no matter how small they uh, how small their validity into the problem statement. They have to be incorporated. Now the great thing here is that it is solely an engineering problem, and because the problem statement is predefined and because it is solely an engineering problem, there can be a very defined solution to it. Now, when it comes to B2C, and I compare it, in this area, I see that the variables are not very predefined in the B2C. I mean, if you are coming up with a product, you can predefine the variables, and cater to a particular problem, but on a day-to-day basis, if it is something as arbitrary as having a robot at your home and having it do some tasks, there are many variables coming into picture, and this requires really higher intelligence. And I know the long picture here is for us to design robots that are human, of human intelligence. Since we are not going there, I think I think right now we can only solve problems that are on that are very engineering in nature. So B2C, I feel the variables are more, and optimization can be pretty challenging. And coming up with algorithms, that do this, can be pretty hard to design. And automation is not like within the product itself. It's not the algorithm that is trying to solve it is not dependent on the knowledge within internally. It has to access the knowledge of the environment around, take that real time, solve, come up with learning probably real time. So that is a hard problem. That's the, and then the integration is another big problem compared when you look at B2C and B2B. Integrating within, across, between two industries uh, can again be predefined. And here with B2C, it's the people factor, educating them and having them really get comfortable, get into, get a sort of intuition to incorporate it in their day-to-day activities.
A common
That
education
is
as
another
well.
challenge. Right, yeah. So I see these differences between them.
Okay, good. I've got one more question about the general context and foundations before we come to specific questions about each of your companies. One question a lot of people are asking is, is this the right time in this COVID Corona era time? Is this the right time to launch a company in robotics or to scale up a company in robotics, etc.? So, how has it played out in each of your cases? Has it benefited? Has it hindered, or a bit of both? You want to start, Raghav?
Um, it really depends on the kind of problem you're trying to solve. If there is a very if you have a very strong use case and you know there's a big problem that can be solved by your robotic solution, then obviously there is now or not now, doesn't matter. Just go ahead and
Yeah,
solve your problem.
yeah.
I would say COVID doesn't change anything as
Change
long as
anything.
you,
Yeah, yeah.
yeah.
That's true.
So that would be my thought on that.
Yeah, that's good to know. What about you, Gokul? You think the same?
I think he is exactly spot on that. It doesn't matter. Trends are trends. It just stays. They do leave a mark. They create something. They might open up doors. They might not open up the doors. But the problem needs to be more relevant beyond the time of the trend. So if that's the case, I think it doesn't matter when you actually open it up. Of course, sometimes sides matter, like fundings and things, and how public attention and things actually come. So yes, it definitely is a good time. Depends, but depends upon what you are trying to solve. What exactly are you trying to build and how you're.
I got it. So both of you saying it's a small spike or a small dip, but the overall curve should be irrespective of this. What about you, Pratisha? You think likewise? You think this is not such a big change in the overall field?
I don't know. I mean, I personally came across friends who are coming up, with unique solutions. I have a friend who is into music, and he is trying to come up with, because the live music industry is going to be affected pretty. The concert, scenario is going to be affected very hugely. He's trying to kind of like live jam with come up with a tool that helps to like live jam with other artists around. So I think this is very interesting, like this I mean, it might be, I am sort of a sucker for experimentation that way. These new ideas are pretty exciting, and I think these new ideas come up within scenarios that are so unpredictable. I so I think we do see problems which we haven't seen before in scenarios like this, and maybe these are not entirely catering to the current problem at hand, but they do solve a different problem. And maybe these problems that they're addressing are some of them can be persistent over time, but some of them can be short term. But in either case, I think I'm not glorifying the current situation here in any which way, any way at all. I'm just trying to say that uh, I think newer problems can be isolated and they can be solved.
Thanks, Pratyusha. You mentioned problems and solutions, etc. So now let's get to more specific questions to each of you. My question for each of you next is, can you talk a bit more about your company, what problem you're solving, and where you are in the journey? I know we have a lot of robotics enthusiasts in the audience, but they would like some tips on how do you spot a problem to solve? How do you know you're onto a good product, maybe? How do you scale up? How do you launch companies' products in local domestic markets and so on? So Pratyush, you want to start? Tell us a little bit about Footloose and the context and where it's going.
Yeah, I mean, it's important to come up with the, problem that is easily scalable, which is quite opposite to what we are doing, to be quite honest. We are trying to, at the stage that we are in, we are trying to test our product. It is in the pharmaceutical warehouse, pick and place, and it's data driven. Uh, so there's a lot of compliance that we are trying to address at the moment. We're trying to test it across many warehouses in the healthcare. Now, because the variables are fixed here, there's a good chance that we can use this particular tool that we are designing in a completely different industry as well, as long as we have the variables under our control fully. So that's where we are at. And COVID has slowed down in the sense that you can't have your one-to-one meetings, and hardware processes are definitely slowed down. We wanted to accelerate our manufacturing, and we haven't been able to do that. But fine-tuning blueprints and that sort of thing has been going pretty. That has been accelerated, given that we are all working from home right now.
Great, thanks. So as we heard, robotics for warehouse management is a very big area to look at, in particular this niche of warehouses for the pharmaceutical sector. What about you, Raghav? Tell us about day zero, how you thought of your problem, where you are, how big your team is, fundraising, the whole story. Start.
Got it. Okay. For me, I have seen my sister firsthand struggle with managing a baby, going to work every day and cooking for the entire family. Back then, I used to think that, mothers were the only superhumans out there. But now, as all of us have firsthand realized that, this struggle is real, not just for working parents, but also for millions of people stuck in quarantine who suddenly now want home cooked food more than ever. The problem we're trying to solve is people want to eat fresh food that is cooked in their own, that is cooked to their own liking in an environment that they have control on, that ensures the safety and well-being of their family. Um, so people want such food, but people also don't want to spend time cooking this food every single day. We're solving this problem by helping people put home cooking on autopilot, by building cooking robots that automate cooking for you. I came across this problem because there was a personal problem, as I just pointed out, right? There was something that I saw, and something that I thought could be potentially big. And then I talked to multiple people, trying to figure out if that problem was actually real, and then started working towards it. Uh, Over the years, we have built prototypes, built products, launched them in a very small scale, made mistakes, learned from those mistakes, and continue to build our team. Currently, we're about 15 people spread across Bangalore, Shenzhen, and Palo Alto, with a prototype that we demoed with consumers in February this year. We will continue to run alpha trials with consumers this year also. We're currently funded by two VCs, which is 0 to 1 Capital and Waterbridge Ventures, alongside Binny Bansal, who's the co-founder of Flipkart, Samay Kohli, who's the co-founder of Grey Orange, and a bunch of other investors who have been extremely helpful throughout our journey. But the stars of this journey would be, the team who immediately works with us day in and day out. Our engineers, our marketers, and everyone else who I've been working with. What COVID has done to our business is, home cooking and eating at home has exploded. Online shopping of groceries is through the roof. Meal kit services, which is a concept very common to people in the US, has again exploded. Shares are like 2x of what they were for meal kit services. And the demand for anything that helps people cook faster or spend less time or effort in cooking at home has increased. So has the list of our beta testers. And we're just trying to continue to solve for that demand. But I would agree with Pratyusha, although demand has increased, our ability to cater to that demand has got severely limited because of the supply chain issues, travel restrictions so far. The way we're solving for those issues is by simplifying our product, doing as much as we can without traveling by the use of equipment like 3D printers, focusing more on the software and the product roadmap than on manufacturing in general, and ensuring the team still works together with their morals high and their spirits high. So I hope that was a long answer, but I hope that answers broadly what you were trying to ask.
Yeah, more or less. We'll come back to some details afterwards also. But Gokul, tell us about your story. Day zero, the launch, the idea, the product, market offering, traction, so on and so forth.
Yeah, there is in your story also as a part of it, or part of my story. But yeah, so it's been a very long journey, in fact, and it's been pretty much more focused because the problem was very evident, was staring at us quite evidently. So though it starts from a university times, it gets its prominence only when I have joined National Instruments, where I started my first job. Along with my partner, we both joined into the same team at National Instruments. So National Instruments is prominently a test and measurement and automation company, mostly from your SpaceX to CERN to most of these companies would be fundamentally building things on platform along with your 5G and 3G and 4G. So a good exposure to wide variety of R&D labs and wide variety of companies. How do they structure their products and where do they come from? And so in the process, we also noticed that since I was specifically a machine vision specialist, it was in a very unique junction where you could see that when the rest of the other products in industry always stresses upon 99.99% of success rates, and when you've automated something, they want 1 in 10,000 as human intervention into it. But machine vision used to fail drastically. For every 10 deployments, only 3 commercially succeeds. And we wanted to understand why exactly that happens and how can we actually fix it. Because if the product is not successful and the customer is not having enough trust about it, so what do we do? I mean, something has to be fixed. Something is wrong with the tech in itself. Because it revealed 2 important things. One, the assumptions that we in general we have, simplified assumptions that we have about vision and its ability. And second thing is boiling down everything to vision's purpose only to object identification. Right? So it is usually treated as, oh, I recognize an object, I tell where it is in the image, so you just calibrate it for your machine to go and act upon it. Right? So the 2 independent systems. So vision might be in feedback, it's an independent system altogether. So we realized that the approach is little more very disparate and it needs to blend together. So that's when we came up with a particular mechanism or algorithm to solve these problems in machine vision. So once we had that, we had some 40 different systems that we could get it as success. Then we thought, okay, so now I have it. But how do we know that independently we could find a market? Can we replicate it? Because you have a method and you're providing custom solution services to the customers, but you're not able to productize it. So every time it takes a lot of engineering. And today machines, if you just change 1 mm here and there, right, the robot cannot go and pick because it's going and blindly picking things and placing things. So in such cases, how do you make the system more object understanding and object manipulatable, right? Which requires an entirely different approach of vision. So that's when we came out in 2015. We tried our algorithms in a variety of different problems where we picked only problems that were unsolved before, so that we can prove the fact that, okay, this works beyond the generically available vision algorithms. Then once we had consecutive successes back to back, then we thought, okay, it's time to prove it, to make it productizable. So that's what happened in 2019 when we raised the fund, and right now we are still building our product. It's on the progress. So yeah, so this is what I was showing. So lucky to have this component in here. So
yeah, what's happening in the picture? Just show us what the components are.
So this is basically two 5 megapixel cams which simulate your convergence with your eye. So convergence is a key factor, so which most of the 3D cams do not parlay into. So it's to simulate that feature by which you could triangulate your movements of your robotic arms to be able to go pick things, or there's a lot of stack that goes behind. I'm trying to simplify it. And also enables you to be much more faster in 3D construction than what it usually happens with your fixed calibrated 3D construction methods. So that's exactly what happens here. So we are trying to accelerate for a 5 megapixel depth. How do you make it fast enough without a projection mechanism, without laser projection or some other mechanisms that typically we use, triangulation mechanisms that we use. So yeah, so we picked it from the lab because the lab was shut due to COVID-19. We couldn't bring the robotic arm into the house, so whatever the components that we were able to scramble up, and we can just continue our work. We're just trying to do with it without affecting the productivity. Yeah.
Very good. Yes, work has to carry on. Sorry, Pratyusha, you saying something?
Yeah. I was just like, intrigued by the equipment. So basically you're trying to like get the target coordinates of the robotic arm and with the help of the camera. I mean, trying to use the camera and the vision to, no? Can you just elaborate there very little bit, if you can?
Okay. So this is more to do with 3D construction rather than to triangulate, because typically robotic arms, you get the coordinates precisely, right, with robotic arms itself, right? So you get up to 20 micrometer precision plus or minus in your all your orientations and X, Y, Z with a Puma robotic arm. So you don't have to bother much about where the robotic arm exactly is, but it's more about a lengthy discussion. So it's more about the limitations of 3D depth construction that we have today, and why convergence helps you to circumvent around that and calibration issues that actually comes with 3D, and how you can construct 3D just with stereo vision and layers of information that comes along with it.
So good, Pratyusha. Looks like you like some of these components already. Tell us a bit about Footloose Labs. How did the company start, and at what stage did you come into the picture, and where's the company going now?
Well, initially we wanted to construct an anthropomorphic arm for pick and place. But the way we went about it was not, I mean, so we were mostly, we had a design engineer and a mechanical engineer and, electronics, and I was basically managing the team, and I didn't join in the beginning. Ankur is the founder of the company, and I actually just returned from US, came to Bangalore, trying to figure out where to start, and I liked what Ankur was doing, and I was like, I just want to see what's going on. He was like, hey, come over, work. But anyway, so I think we were trying to initially cater to the senior citizens in the healthcare to have a pick and place system in their homes to do specific tasks, like at least 2 or 3 tasks in a very defined way, like cleaning or picking up water, things like that. But I mean, I think the challenge that we had definitely was trying to have the opposable thumb uh, incorporated precisely to have the pick operation, being optimized. We failed to do that. And I think at that point of time, I stepped away from Footloose. I'm director and part owner of the company. And now we have come up. Now it's a different product entirely. We are looking into the pharmaceutical warehouse space, and the problem is much more defined, because what we are trying to solve is we were trying to solve initially is to have such a system at a very low price, and uh, to have that leverage, like with price and functionality. It was difficult for us to define, and over time we've realized where we were going wrong.
Okay, got it. So my next question is, how did the market react to your offerings? How did you educate the market? Typical sort of marketing hacks are you come up with a use case scenario and you explain to the customer that this is how it would work and the problem it will solve. Another one is to use a metrics-based approach and say, look, you're losing so much because of this inaccuracy in your process. If you use a robot, you can save XYZ percentage, etc. So how are you approaching your market? How are you getting your market to be interested and excited about the technology and the solution that you have? Gokul, you want to start?
Yeah, sure. For us, it's a little bit easier, simply because it's B2B, and there is one mechanism, one structure for us to approach even the customers, and the customers have already defined the problem, like how Pratyusha actually has been mentioning, right? They are pretty much many a times very clear about what is that they need, and how is this particular solution is going to help me, and they are in the seek out, rather than me having to go say that, hey, I have built something of the sort and it's going to be useful for you, and why don't you replace a human being there and then you just put a robotic arm. It's rather it comes from them asking, hey, I need to be able to replace this human being within this budget and this limit, and how do you actually, do you have a solution, or do you have a product for it? So where the issue comes is mostly about the tech naivety and the tech assumptions that they have, that, oh, you have a camera, you do the typical comparison that comes is like, okay, so they have a cam, so they have an algorithm. It's able to detect that object. If that is able to detect the object, so it should be able to go and pick it. So why is that your system not able to pick? So that's kind of, so why is that it has to be this sophisticated to be able to do it? It's mostly on the tech education part and the tech awareness part, and both in the, so people who have already attempted, they're wary of machine vision. They say, if you have a machine vision based solution, I don't want to take it. Right? So that's at least in India, that's a very big, or at least we have several customers who, even in US and Germany, they have this aversion towards machine vision and its issues. Incidentally, I was reading one more article today about how Apple attempted, and then what's happening with their robots attempts in their factories. So initially, vision always appears like it will work, and you make one tinkering, it will again work. You make one tinkering, it will again work. It will keep going on that way because it's a lot more relatable to us. But the issue is the subtlety in which it actually is lost. So those things, but why it is the sophisticated to get it done, and what it actually costs, what to anticipate rightly around it. But yeah, otherwise we didn't face much issue about the use case of this tech. Why it is needed is not to be convinced, but why it's hard to get it done is what typically takes little education with.
Yeah. How about you, Raghav? Very often techies have a hard time connecting sometimes to the customer. What is your magic sauce in getting customers to understand what it is that you're doing?
I think you asked the question very well, which is, I think in the question itself, there is the answer. The answer is we abstract the tech out of the offering. We don't talk about the tech at all. We try to just position the benefits that our users will get out of our offerings. We tell them that we have built. We don't, many times we don't even use the word robot. We say we have this kitchen appliance, or we have this machine that automatically cooks food for you. We say put home cooking on autopilot. But we dumb it down to the language that our consumers understand on the channels that they visit, which might be Facebook, which might be Instagram, which might be blogs that they read. and only once people are convinced of the value prop that we are bringing to them, they land on our website, click on the technology page, and we try to break down our technology as much as possible so that they understand how the tech works. But typically in our first interaction, we don't talk about the tech at all.
How about in your case, Pratyusha? How do you approach the market? How is your company educating pharmacy owners or warehouse owners?
Right. Right. I think the way I see it, integration shouldn't come after the construction of the, the tool. It is B2B and everything is process driven. So integration has to go in hand with the building process. So it's important that we work with them, isolate every problem. First of all, make them aware of their own problems and see that make them see that this is the solution. Sometimes it is hard for them to see that robotics is the solution, automation here is the solution. So first it is that, and then while the construction, we work hand in hand with them to properly define the outcome.
Okay, I just have one or two quick questions before we take the audience questions. We got about 15 minutes left. So my next question for all of you is about IP, intellectual property, patents, that kind of stuff. I guess you're in very high-tech sectors and a lot of big competitors are there. All the big IT giants from Japan, Germany, etc. are there. So how do you build your moat? How do you build your competitive advantage? Are you guys filing or have already filed patents, or are you licensing other people's patents? How does it work? You want to start, Gokul?
Yeah, we do have patent filing on the process, and it's quite important. We see it more from not from the tech protection point of view, but not limiting us from building further. Because if say I don't do it and somebody else does it, and I'm not allowed anymore to proceed further in progressing in my own way, because essentially it's legality is through a language, and language is always abstraction, and people can always figure out ways to work around your phone, your components, your anything that you build. Let's say iPhone, Apple builds an iPhone and Samsung builds another phone. Right? So that is always there. It's just that it shouldn't stop you from progressing forward. Right? So that's the key factor to it. Plus, it's an asset. It's for us, it's effectively and definitely for us, it's a especially IP rich, and all three of us, in fact, for the case, it forms a significant value for us to build the IPs. So yeah, we have broken down into, so there are several layers and several methods of approaching, or classification that you can actually see from for the IPs, varieties of IPs. So we segregate that way and make sure that we have a pipeline of IP that happens.
Raghav, how much are you paying in lawyers' fees and those kinds of things?
So we are paying money, but we do focus on IP, but we also ensure that the organization's entire focus is not just on IP, because it's too easy to create IP that nobody might use.
Nice. Yeah.
So hence we try to steer the organization's focus away from generating IP. The focus is on generating value. That being said, every time we generate some value, we give the value to our lawyers and let them figure the IP bit. But I feel that the focus should more be on the value you're creating. Patents is one way, of course, but one more way that we protect our IP is through trade secrets itself. We know there are things that we've built or are working on which might not stay with us if we actually file for IP. So we just keep them as trade secrets. Things of such yeah, things of such sort would be, for example, formulas for the recipes that we create. Because we're building a cooking robot, there is a recipe that the cooking robot has to make. That recipe has to be translated into a language that the robot understands, and then the robot cooks it. So, for example, all of that, we don't really file IP for that. Yeah, Pratyusha, sorry. Sorry to
Sorry,
cut you
go
off.
on.
Please.
Pratisha, you were earlier at an MNC. MNCs are very heavily IP centric. So what's it like for you in your new role with this startup? How is your startup approaching IP?
We are filing, I mean, we are in the process of filing IP, but the the way I see it is we construct, a tool, hardware tool. It is so easy to, see through and through it and back engineer it and construct it back. And even the software side of it is not that difficult to um, replicate. Now, I think the laws are not properly placed in our country. It needs stronger laws to protect such IPs so that, all of that original work and innovation doesn't go waste. But that aside, yeah, even when I was working in Intel, it it was pretty intense. All the Intel proprietary equipment. I don't see any of that. I never saw any of that equipment anywhere. The labs that we were working in, all those laser assisted device altering laser, shooting equipment. It's pretty insane. Yeah.
Okay, let's take a couple of questions from the audience now. The first question is about questions of ethics and regulation. So, what are some issues you guys are facing? Are you running into any ethical issues of man versus machine kind of thing? What kinds of regulatory obstacles are you facing? Is your area very heavily regulated? I'm guessing maybe pharmacy sort of could be regulated, healthcare, industrial accidents, whatever. All these kinds of issues tend to crop up. So, Raghav, you want to start? What are some ethical and regulatory issues in your field?
So, from a regulatory standpoint, in our case, we are governed by the same regulatory standards that any, say, kitchen appliances are governed by, which is we need to ensure that people are extremely safe when they're using our products in the kitchen. In our early prototypes, we had a robotic arm being used as a consumer product, 2 years back as our early prototypes. People were definitely scared because a robotic arm could just strangle you to death at your home when there is no protective cage. But we've now shifted to something which is more like a consumer appliance, and we're governed by the same safety and hygiene standards that all kitchen appliances are governed by. From an ethics standpoint, I feel that the same kind of ethics should be applicable to robotics companies that are applicable to data companies or privacy companies. Although they only have digital data of our searches and online actions, robotic companies might have data to not just online actions but also physical offline actions that you do. And I think we should be just governed by the same set of ethical rules. Not much in my industry has changed that way. There's the question of liability, though, which is in case something goes wrong, who is there to blame? Which is a debate that has been happening again in self-driving for the longest time. But in our case, that is not a big debate because kitchen appliances have already, automated cooking to a minor extent, and those same standards apply to us.
How about you, Gokul? What kinds of legal landmines or ethical issues are you wrestling with?
It's pretty objective when it comes to industries because things are already very well defined and there's a very large segments of rules and procedures and safety standards and there are even products, an ecosystem of products that are available to make sure that you integrate all of them and make the system to be protected enough. And yeah, and things are very clearly defined, like who's going to take the liability and how the information is protected, and there are NDAs that are signed between the customers. So it's pretty much it's not wild. Like in case of autonomous cars, you'll have to figure out a lot of things. You'll have to figure out, it's a very new thing when it comes into it. But when it comes to this B2B, or at least in manufacturing, it's kind of very clear and already a set forth rolling legal system. that's in place.
Oh, I think we just lost Pratyusha, but let's take the last question now. We have just about a bit more than 5 minutes, and the last question is about the interface issue. For so many years, the interface with humans and machines has been the keyboard, the mouse. Now we are seeing voice, we are seeing gestures. So, what is the future of communication between humans and robots? Any comments? Any futuristic views? It's a good last question, actually. Gokul, you want to start?
So yeah, so it's pretty much moving. There are joysticks, there are buttons, there are so many ways of interfaces, but it has been a physical wired communication that comes into it. This physical wired thing, there's a lot of technical limitations to having wireless. In metal absorbs a lot of RF, and attenuation is heavy, and you also have prolonged distances onto which you can do so all those things. But the future where we definitely see is rather having to always type and do things, gestures and things are the ones that can make sure that in spite of robots, somebody will have to train robots tomorrow. So that could still be the people who's best to train it, not the guys who actually write the code, but the guy who has already done the task, and it should be able to replicate him. Right? If someone is hammering something and he's able to hammer it so well, or someone is able to cook something, if a chef is knowing how to do the knife, and that should be much more easily replicable into the robot, and it should be able to read to it. That's the kind of augmentation and interfaces that would be really, at least I would be looking forward to in the future.
Got it.
So,
how about you, Raghav? Will there be a day when I just think of a recipe and your robot will cook it for me, kind of thing?
Yeah, I think there might be a day, this question is really like it's application specific. As more applications open up which do not require your laptop, more interfaces will open up. It is difficult to foresee what those interfaces would be. I mean, there were touchscreen laptops, but people still use their keyboard. So there can be interfaces, but it depends. But I have my hopes high on mixed reality and virtual reality as a screen interface, as an alternative to the screens. Those are my two thoughts.
Okay, great.
Pratyusha is back.
Yeah,
Pratyusha is back.
guys.
Yeah, that's okay. Pratyusha, maybe you can just I'll just throw that one question to you. Are there any legal, ethical issues you're facing in your company and robotics in general? What are some regulatory issues in your domain, for example?
At the moment, I don't know. I have to really check because I stepped away from the actual project. I have to look into it closely. But as far as I know, I nothing significant at the moment. Ethically, no. But usually, ethics in robotics is a big issue which stretches across so many disciplines, especially in B2C. But since we are B2B and it is within the within the four walls, at least like at an operational level, I don't see any significant ethical issues coming up.
Okay, great. Well, good to have you back, but unfortunately, we're out of time now. So, Vinay, over to you. Thanks once again to all these three panelists for their outstanding insights. Thanks to the audience for sending us all your questions. Vinay, what's next? What's your next event about? And any closing notes for our speakers over here today?
Sure. Thank you, Madan, for your time, sense making, and connecting the dots. I think I like the way how the panelists came about their ideas and use cases. Pratyusha spoke about the musician and how I experienced abroad, while Raghav spoke about his personal use cases, cooking at home, his sister being a superhero, and Gokul spoke about his experience at National Instruments, the vision algorithm, and all of that. So I think we have been doing 5 deep tech topics now over the last couple of months. And it's a good time to share the learnings on your story and other platforms, which we will be doing soon. And also next week, we're trying to see if we can bring in, parents of pets and toddlers who are working on tech and other solutions. So I'll share it with some of the entrepreneurs in that space. I'll be happy to share it with you as well. And as I'd also like to thank the other team members. So in fact, the robotics quiz was brought together by 18-year-olds, a couple of 18-year-olds. And then we had a documentary that was shared by them. We had a few questions from the audience. So it goes to show that it takes a lot more people to actively engage and participate to pull learning and development around events. So again, thank you so much. and we will stay connected. And if anyone wants to connect with you on questions, thoughts, I'll be happy to share it with you.
Thanks, Vinay. Everyone have a good weekend, whatever weekend means these days. Weekday, weekend is all blurring together, but
blended up now. Yeah.
try to unplug for some time and rest before the next week begins. Thanks once again, Vinay. And once again, thanks to all of you, Raghav, Gokul, and Pratyusha, and to the
Thanks,
entire
Madan.
Cloud Product team. Bye.
Thank
Take
you.
care.
Thanks a lot,
Thank you,
Madan.
Madan.
Thanks,
Bye,
Vinay.
Madan.